We're currently in week 92 of a 190-week program. So on site, the superstructure and frame is very near topped out. So we've nearly poured 30,000 cubic meters of concrete. We're about halfway through the program. So the facades are well on. We've got 1.2 million bricks and about 23,000 square meters of glazing, which makes up the facades. And we've got to deliver 743 apartments, along with an energy centre and a 4-acre park which surrounds the project.
So on this project we're using off-site pods similar to we did on a previous project for the same client. And one kind of issue we noticed on the last project was to do with the finished floor level. There was an issue where the tolerance of the RC slab meant that if it was built low or if it deflected more than it should do, the floor level would have to be built back up using more material, costing more money. So using that lesson and having identified that commercial risk, we realised that on this project there were two things that we had to monitor. One of them was the as-built of the RC slab, and the second one was the deflection of the RC slab. Traditionally this would have been done using total station, and the problem with that is you take spot levels and you could miss some critical data. So what we decided to do was utilise 3D point cloud scanning, which essentially takes the same amount of time but collects a lot more data. So the equipment we decided to use to carry out the 3D point cloud scanning was the MS60. It's a Leica total station but just a high spec version. And essentially what we do is the day after the pour we set the total station up and we perform a scan which gives us a picture of the workmanship of the slab really, and making sure that it's within tolerance. This data is then collected, taken back to the office, given to our BIM engineer, and he can basically, using 3 pieces of software, import it into the model where that as-built is collected within the BIM model. But he can also produce a heat map, which is a drawing with the GA of the floor and an array of colours. And essentially each colour is a deviation from the datum level. This process is then repeated once the slab is struck, and what that does is it allows us to capture the same information but for deflection instead of workmanship. So when the heat map is produced, based on the colour, it will tell us whether it's high or low, and the contractor basically is given an NCR and either has to grind it down or build it back up. There was a previous job where I was on where the floor build-up was floor battens, so the build-up was about 220 mil, and in that particular case it probably isn't worth doing this. Where your floor build-up is only 25 millimeters, as in our case, this is definitely a worthwhile exercise.